I think everyone can agree that colors are great. In a data visualization, you can use them to gray out everything else and then highlight a few points with colors so that you can draw your reader's attention immediately to that specific point that you want to highlight. And that gives you a lot of power and control of what your data visualization is about. Also, sometimes colors are just nice because they make your data visualization more aesthetically pleasing, and if something is nice to look at, you are more inclined to believe it, or you will think that it's a more serious data visualization. Someone put a lot of effort in it and it shows, and this will give you a lot of credit if your data visualization is also aesthetically pleasing. Of course, you should get your content right too. You shouldn't just draw a pretty picture. So let's look at 4 principles that will help you to use colors more efficiently. Let's go through them quickly and then we can head straight into ggplot and I will show you how you can implement these principles. The first principle is to use shade, not hues. You do not need to use a new color for each category or whatever it is you want to visualize. Just use the same color and make it a little bit transparent or lighter. And this way you get different shades, but it's still the same color and your visualization will look more consistent and it will look less like a colorful rainbow plot. If you adhere to the first principle, then the second principle will go smoothly. You can use different colors for different categories and then you can use different shades for subcategories. So say you have 3 large categories and in each one of them you have 1 or 2 subcategories. Then you can use the 3 main colors for the big categories, and within these categories you can keep showing each subcategory and use a different transparency for each one of those subcategories. This way you can show all of the subcategories, which is a lot, but it won't feel overwhelming because you have grouped them together with this one specific color, and then you have some differentiation with the different transparencies. The third principle is to emphasize just one or a few categories. So instead of assigning a different shade or a different hue to each category that you have in your data, you pick only 1 or 2 categories that you want to assign a color to. This way you can emphasize your data and tell a story and make sure that your reader is drawn to that one specific part in your plot where you used colors. When you gray out everything else, then it's like a really strong sign that the reader needs to look right there, and this can give you a lot of power to make sure that the reader will see the message that you want him to see. The fourth principle is to label your data directly. Instead of using a legend, you can put a label directly into the diagram. What do I mean by that? Usually you will have, if you use colors, you will have a legend on the right hand side of your plot that will say red corresponds to category A, blue corresponds to category B. This will take up a lot of room on the right hand side that could be used better. If we avoid the legend and put the labels into the plot itself, then you have more room for your data to breathe in. If you label directly, then your reader also won't have to go back and forth between the legend and the actual plot. This can save a lot of time for the reader before he understands what you actually mean. If the label for the specific timeline or whatever it is you plot is directly there where the reader is looking at, then he will immediately get it. If he has to look at your plot, see a color and then go to the legend, okay, this means that, go back, I forgot already what that is, go back again. This will be tedious and it will take a lot of time until your reader understands it. If you put the label there directly, then you've got an instant gratification because your reader immediately understands what you mean. So this was a quick overview over the 4 principles that we want to look at in this video. So now let's head over to ggplot to implement them. So we're here in our studio, and as you can see, I've set up a new quarter document and I've set up first code chunk that changes a few default setting of ggplot, like the appearance, so it should look like theme minimal, and I want to use a different plot and I want to have the title moved somewhere else. This is basically the same setup chunk from my blog post. So this video is based on a blog post that I wrote a couple of weeks ago, and there you will find the same code chunk, but don't worry about it. I will have a different video on how to change fonts and how to use icons later on. So let's run the code chunk. It will load a couple of seconds because the font needs to be added, and in the meantime let's get our first visualization that we want to improve. So let's look at the miles per gallon data set. If you've learned ggplot already, which I assume you did, otherwise you probably wouldn't watch this video, then you will know it. As a reminder, here it is. It contains a lot of information on car models. The first visualization we want to look at considers how many classes there were, as a car classes there were in the years 2008 and 1999. These are the only 2 years in this data set. So let's do this. So let's send this to ggplot, and on the x-axis we will have year, and on the y-axis we will have we won't have anything because this will be counted for us, but we want to have the bars that we will plot filled with class. So let's make this gm bar, and there you go. As I said, that's a rainbow plot. We have a lot of different colors, and it is a mess because here the reader really will have to go back and forth between the legend to figure out, okay, which one was which. So which color was which car class. So how do we use less colors? We will need to assign group labels to the different car classes, and this way we'll create 3 larger groups so that we do not have 1, 2, 3, 4, 5, 6, 7. Is that correct? Yeah, 7. It is actually 7. So that we do not have 7 colors that we will plot, but only 3. Let us drop a new code chunk where we will put in a new data set. So let's do mpg and mutate it so that class will be, let's do a new variable class group, will be assigned a label group 1, group 2 or group 3, and we will pick the first 3, 2-seater compact midsize to be group 1, minivan to be group 2, and pickup subcompact and SUV to be group 3. So we can do this with this in operator or with case when. That's the easiest way to do this. So there you go, we have a new column. Let's save this new data set in a variable dat, and then we can take the plot from before, and instead of putting the fill aesthetic, mapping it to class, we will map it to class group. So there you go, we only have 3 colors now, but of course this will get rid of all the other labels. We still want to see what is a compact, what is a subcompact, and so on. And the trick here is to use, as I said, shades, not hues, and therefore we will also need to specify the shades. And how do we do it? We do it with the transparency, with setting alpha to the class variable. So alpha should be mapped to class. Okay, now we have mapped the transparency to the class variable, but of course now some values will be won't really be visible. So therefore let's tweak this a bit more by specifying which alpha value to use for each class. And also let us change the default colors to maybe something colorblind safe by using the Okabe Ito color palette. I've copied a code chunk from my blog post where we basically do this. We get vectors that contain the colors here, and we determined alpha values. Since I do not want to get completely transparent blocks here like the one on the top, I've set the minimum value to 0.7 and the max value to 1, and I've constructed a sequence so that we get somewhat equidistant alpha values. And now we can use these to specify the alpha values manually. We simply add a new scales layer to our ggplot from before. So let's take this one here, and we will need to change the fill layer because we want to set it manually, and then we simply state the values are the colors that we used up here. And the same thing can be done with the alpha aesthetic. And the values are supposed to be these here. Now we have 3 colorblind safe colors, and we have used the shades in a way that we won't get completely transparent blocks, but the transparency is different enough so that we can differentiate between these blocks here. Notice that we still have 2 different legends in this plot. Of course, we will only need one. There is no use of having one legend for the transparency mapping and one legend for the color mapping or for the fill mapping. Therefore, we will need to change the legend manually, and this is done via a guides layer in ggplot. The guide layer works by defining a guide or a legend for each aesthetic that you mapped. So for instance, for the fill aesthetic, we mapped, we do not want to have a guide, so we will put this to guide none. Let's see how that looks. As you can see, we got rid of one of the legends, and we still are left with the legend we want to have anyway, with the legend that gives us the car classes. Now all that is left to do is to get the colors that we have in our bars into this legend. Use the guides function and determine what the alpha guide is supposed to be like. And in here we will need a guide legend. Let's do this, and you can see the guide legend without any argument is just what we have anyway. This is the default value. And within this guide legend function, we can now determine what the legend is supposed to look like. If you look into the documentation of this, you will find that there is this override aesthetic argument, and this is what we need to override the legend. As you can see, it needs a list, but once we understand that we need to put everything into a list, we can now simply state, okay, the color needs to be, let's make everything one color. You see, now we changed the color, but the block is still has the same color, so let us not override the color, but the filling. Now let's make sure that the legend displays the correct colors. The way to do it is to pass a vector of colors to fill that correspond to the colors we need here. So we need a vector of length 7 that contain all the colors. So the first 3 arguments need to be the same color because all of them are to be this type of orange. Then we'll have this type of green, and then we'll have the blue ones. You see, with this vector notation, we get a vector of length 7 where the colors, the first 3 colors are the same, then it's the green color, and then it's the next 3 colors. And now if we execute it, you will see that this now looks the way it is supposed to. So now you see that we can use less colors and use shades instead of hues. And if we want to remember that, we could put this into the title. It is use shades, not hues. And there you go. We have a clean picture now that shows us what we want to remember. In this case, it is to use less colors. The second principle runs really smoothly with this first principle because we already used less colors, but we still want to make sure that the different groups can be recognized immediately. In this bar plot, we can see the differences between the colors, but they're not immediately visible. The quickest way to make sure that we can actually easily see the differences between the colored blocks is to add small borders. So let us add a white border for each block. We only added slight white borders here, but the groups are now more visible instead of if we had left them out. The third principle is to emphasize just one, two, or really only a few categories. Here I want to demonstrate this with a data set that I got from our world in data. I've downloaded it as a CSV file and I can read it in with read CSV. I did some data wrangling with it. That's not important. You can get the code chunk from my blog. This data set is about who we spend time with as we get older. Actually, in this in the original file, it's probably easier to see. So let's only take a look at the data before I rearranged it. So for each age, so let's say with 16, we spend 206 minutes alone, 111 minutes with friends, with 28 minutes with children, and so on. And for each age, we get similar information, and I've rearranged this with pivot longer so that we can actually throw this into ggplot, so that we get a different line for each person we spend our time with. So let's throw that into ggplot. We want to have the age on the x-axis, the minutes on the y-axis, and we want to map the color to person, and we want to have a line plot. Let's make this a little bit bigger. As you can see, this is messy. This is a classic spaghetti plot because you have a lot of different lines, all colored differently, tangled up all over the place. What we want to get is to take just one of them and highlight it with color and gray out everything else. Actually, before we gray everything out, let us make sure that the colors we use are colorblind safe. So once again, let us call the okabe-ito function from the thematic package, which will give us the colors from this colorblind safe palette. And in this case, I don't want to have the sixth color. I want to have it taken out, and this will give me a vector of colors, and I can manually set the colors by specifying values is equal to colors. And now we have a little bit better colors, but still this is messy. Let's use gghighlight to highlight specific parts of this plot. gghighlight is really easy to use, so let me simply demonstrate it, and then you will immediately get how it's used. Of course, we will need to load it first, so let's execute library gghighlight. Then we take our plot that we had anyway, and then we simply add another gghighlight layer. And the only thing it needs is to get to use filter conditions. All of the filter conditions are then used to determine which lines are highlighted. So in this case, we want to highlight maybe the time spent alone. So let's use highlight only the lines where a person is equal to alone. it's really easy to use. Everything is grayed out, but the one line we wanted to get. Also, you will notice that there is already a label in there. If you want to label manually later on, which is what we will do, then you can write skip. I thought it is skip. Let's take a look at the documentation. Use direct label should be set to false. And now this label is gone, but we have a legend once again. We will fix that later on, but for now, marvel at how easy it is to highlight specific parts of your plot with color using gghighlight. We can immediately tell stories. Check out how I can easily set a narrative into this plot by simply adding a text notation at somewhere in the plot. So, as I said, we want to have an annotation, which is supposed to be text. And then let us put this at x is equal to 20. So I want to have it on the top left corner, and y is equal to, I don't know, 450. The label, so the text that we want to display, is supposed to be the narrative I want to spin. In this case, I want to spin, I don't know, I just want to say, we spend a lot of time alone, or from the age of 40, we spend a lot of time alone. We need to get this into the correct spot. So let's put age just to 0. This will make it left centered, so the text actually starts where I put the coordinates and not the middle of the text. This is why the text was outside of the box. Let's make this larger. Okay, this is probably too large, but let's see if we make the text family into Fira Sans, which I like to use. It's still too big, but we can also move it a bit. 18, and let's make this 9. There you go. I will leave it as it is, or maybe I will put it back to 20. Perfect. Now it's aligned with this line and it feels maybe a bit smoother. Here I've used the age 40 as a threshold to say from the age 40 we spend a lot of time alone, because this is where I can see that the alone time really goes up. But what we could also do is to not highlight only a person line, but also a different line. This one here looks like it goes into the opposite direction. So maybe that's a story we want to tell. So in this case, I already know, because I've looked at the data, that the other gray line that I just mentioned is the line that corresponds to children. Now the green line is also labeled, and because I want to tell the story that from the age of 40 and up something changes, I can only highlight that specific part of my plot. So into gghighlight, let us put another filter condition. Let's put age is greater or equal to 40. Now maybe let's do 39, because there the lines go together. It looks nicer, but I still probably want to use the age of 40 in the text. So we could change our story from the text we have seen here to from the age of 40 we spend less time with our children. We'll probably need a line break, so let's add that. Children and more time alone. See how that looks. I want to have v just equal to 1. I will need to make the line height smaller. I want the text to be compressed. Got a comma. And also if I'm doing a line break, I shouldn't add a white space. Now this a bit more line height, maybe a bit more. Finally, let us come to our fourth and last color principle, which is to label directly. We have already seen that gghighlight can do that for us. For instance, if I do not set this option, use direct labels is false, then we get direct labels. This way we can see here that the labels of the categories are attached close to the actual line, which is of course helpful because it gives us more room for the data because we do not need the legend in here. We could format the labels in gghighlight. If we look into the documentation, then we could use the label params and give a list that can describe how the labels are supposed to look like. For instance, we could change the colors, or not the colors, that wouldn't make any sense, but we could change the size of the label so that these labels are larger, because right now they are really small. But in this case, I do not want to use these kind of direct labels here, so let's get rid of them. Instead, I want to take the narrative I have included anyway, the text in here, and highlight specific parts of this text to include the colors that we use here. So what do I mean by this? I want to get rid of this legend person here, just as we did before with the direct labels, but I want to not put labels somewhere here close to the end of the line, but I want to put it directly into my narrative, where I would write alone in this orange color, and I would write children in this green color. I should probably mention that this kind of labeling introduces a kind of conundrum once again, because it has the same drawback as the legend, because maybe people will have to go back and forth between the color in the text and the color of the line in the plot, and maybe they will forget. In my opinion, it is worth this small drawback, because I believe if you spin a narrative, people will likely remember the colors better, but that's just a matter of taste. If you really want to make sure that people can look at the line and cannot forget what color this is or what category this color corresponds to, then use the direct label anyway. Okay, so now let's get rid of the legend and get color into our annotation. The first step is easy. Getting rid of the legend is just using a theme function and stating that the legend position is supposed to be none. There you go, the legend is gone. Now let's focus on the color in the text. One ingredient that we will need for this is another package called ggtext. Let's load it. With ggtext we will have access to another geom which is called rich text. So let's annotate not a text but a rich text. As you can see, the behavior is a bit different. For instance, our indicator for a line break somehow didn't work at all, and we have a border around our label. Let's talk about the line break first. The line break can be set not by \n, but with this break. Where does this break come from, this notation? Where do we know it from? If you've ever used HTML, then you know that there you can use this break label for new lines. And this already tells you that this ggtext or this rich text geom uses HTML notation. But this way we already know that we can use all other, not really all, but important HTML text to work with our text. In this case, it will help us to put the correct tags, like span tag, which you will see in a minute, around the words alone and around the words children, and this way we'll specifically highlight these words using HTML magic. First off, since we will, this string, this text will become really long because we will add HTML text to it, it's probably best to not put this into the ggplot itself and save it into a variable. So in this case, let me call this h40 text, and with h40 text, let's save that here. I shouldn't have included another set of quotes. And now let's put a span tag around alone. This is the notation. And once again, everything works fine, the plot looks the same, and this tells you that the span tag is more or less what we have by default. But within the span tag, we can now put in options like colors or whatnot. In this case, we can adjust the style argument. And really, this is something I will always look up because I forget the syntax. You have the code on my blog. So for this very specific example, you can find the code on my blog. So if you forget, just take a look at that code and then you will know, okay, I need to change the style argument if I, for instance, want to change the color. So yeah, you know where to find it because I can almost guarantee you that you will forget it. The style argument works by using a string. So in here we can now say color is equal to, let's just call it gray 18. Let's see if this worked. No, it's complaining. Oh, actually it complained before and I didn't realize it. I, of course, need to not use backslash, but /. As I said, you will forget the notation, and this is why it's good that you have some code that you can look it up. But if you do it like this, now it works fine, and we have adjusted the color to gray 80. Maybe we want to have gray 50. So now we know how to change the color. Let's get the correct color in there. Let's have a look at colors, and I believe this is the correct color. Let's try this out. You can use, instead of words, you can use the hex codes. You do not really want to use copy and paste in this kind of situation, because if you change your color palette, you will have hard-coded the colors in here. So let's make this a variable instead. What we will need is to generate this text here, this text string, via a function that puts the correct color into the place we want. So here, instead of this hex code, we want to use, I don't know, colors1. Because if you would execute this in here, you would get the correct colors. The way I like to do it is to use the glue function from glue. So the glue package gives you the glue function, and as the name implies, it will glue together the text that you give while executing code that you use within this text. But to make sure that the function knows what is code and what is text, you will need to wrap the code into these curly brackets, and this way it will you will get an output that puts the correct color where you want it. By the same logic, let's also colorize the children. Now I need to know which color is the right color for children. Let's try this out. Okay, this is not the one. This is also not the one. Ah, there you go. I should have started with 2. So the way to change the text box can be found in documentation of ggtext, and honestly I will always have to look it up, so I will do it in this video too. If you scroll down, you will find all of the aesthetics, and there is this argument label color. And if we set this to null, it should work. Okay, this is not good. To NA. Using NA instead of null gets rid of the border for us. Okay, I think this demonstrates our last color principle quite nicely. Of course, you can do it with other kind of plots as well. You do not necessarily need to look at line plots like here. You could also do the same thing with the bar plot we did before. Just for completeness sake, I've copied and pasted the code from my blog post into another code chunk, and if you execute it, don't worry about it, you can look up all the code on my blog. We have direct labels once again. Nice, so we've learned to implement 4 very easy color principles in ggplot, so let's do a quick recap. The first principle was to use shades, not hues. Don't be a fool and use 1,000 colors to create a messy rainbow plot, use only a few. The second principle goes right into the same alley as the first principle, use only a few colors for large categories and then use the shades, transparencies for the subcategories. This way you can show all of the subcategories that you want, but it won't be a mess. The third principle was to highlight just 1 or 2 or maybe 3 colors to emphasize the storyline that you want to tell. And the fourth and last principle was to use labels directly. So avoid a legend where the reader has to go back and forth between color and the plot and color on the legend. Instead, put a colored text label directly into the plot. As we've seen, the last principle also works nicely with the emphasis from the third principle, because this way you can use your direct label to highlight the points of the narrative that you want to spin. This concludes my video. I hope that you enjoyed it and that you learned a lot. If you liked it, hit the subscribe button, and if you want to see the full story on where I learned these data principles from, and if you want to see the code chunks again, feel free to check out my blog post with the link in the description below, and see you next time.